We are on the Inquiry Lab, Solving Inequalities, on page 493. And we just got done talking about some geometry and some angles, and we're not done with those, but we're going to take a couple days to bop back and talk about inequalities, and then we'll apply it back to angles. So I'd like you to read with me the first scenario, and our question is, how is an inequality like an equation? Okay, well, just to review, an equation is something that has an equal sign. An inequality is an expression with a symbol that's not an equal sign. So it could be any of these choices are inequalities. Less than or equal to, less than, greater than, or greater than or equal to. So I want you to think about that today. How are they different, and how are our solutions different? So here's our scenario. Mr. McKenna volunteered to drive Hinto and his friends to the school dance. The car can carry up to 5 people. If you can circle that, please. Including the driver. How many friends can ride in the car with Hinto? Well, think about the phrase up to 5 people. What does that mean? Well, that means you could have 1, could have 2, could have 3, could have 4, could have 5, but we can't exceed 5. Okay? So, what do we know? We know there's got to be one driver. We also know that we can't exceed 5. 5 is going to be our maximum people in the car. So what do we need to find out? We have to figure out all the possible numbers of friends he could take. Okay, so if you look down here, this is how we would model this with an inequality. Okay, well, we've got this unknown variable x, plus we're adding 2. And if you look in this little box, it explains why we add 2. Okay, we're adding 2 because we're assuming that we have a driver and we have Hinto. To that, we're going to add x is the number of friends that he's going to take with us. And when we add that to the driver and himself, we cannot go over 5. So that's why we use the symbol less than or equal to. We could be exactly 5, or we could be any combination less than that. Okay, so it doesn't take much to realize that that means x could be 1 friend, x could be 2 friends, or x could be 3 friends. Right? Because 1 friend means there's 3 total in the car, 2 friends there's 4, 3 friends means there's 5. Okay, so that's kind of our solution that we're thinking about. So over here, if you can please write this inequality. This is today's lesson. We are going to treat this inequality just like we would treat an equal sign. So we're going to divide it into 2 sides, just like a teeter-totter that's balanced, and we are going to isolate x. So in order to get x by itself, we need to subtract 2. At this point, these are additive inverses, so they're going to circle out. And we get x. But this time, instead of bringing an equal sign down, we actually bring down our inequality symbol. And this means that x is less than or equal to 3. That means the number of friends can be anything less than or equal to 3. Well, if you look over here, we already realized that those were the possible number of friends. And I would say there's probably one more possibility. Couldn't he bring no friends? Okay. How come in this scenario, -1 is not an answer? Isn't -1 less than or equal to 3? Yes, it is. But in this context, can you have -1 friends? No, you can't. Okay. All right. Turn the page twice to page 496. So we're going to try to work with some word problems and see how you would put those into an inequality. So the first one, Yolanda wants to score. Please circle the word at least. We want to focus in on these phrases. At least 84%. When you hear at least, that means we're okay with 84, but wouldn't we be happy if it was more than 84? So if you look over here, at least means we want to score something greater than or equal to 84. Okay, to see a certain movie, you must be, please circle the word at least 13. I'd like you to circle what you think is the best choice there. Number 6. Kai had $4.99 left on a music download card. She has a download costing $1.99 in her online shopping cart. How much money does Kai have left to spend? Okay, well in this case, she has $4.99 left. That means she can't spend more than $4.99. That's her upper limit. She already has $1.99 left in her cart. So she has something plus $1.99. This is going to be her total purchases. Do we want the total purchases to be less than or equal to $4.99? Or do we want them to be more than $4.99? Well, since she only has $4.99, we want what she spends to stay under that so she doesn't go in debt. In some states, teens must drive. Please circle at least 16 years of old to obtain a driver's license. Can you look over here and try to figure out what age must you be to get a driver's license? Does your age have to be less than 16? Does your age have to be less than or equal to 16? Does your age have to be greater than 16? Or greater than or equal to 16? The Walter family budgets a maximum amount of $125 per week for groceries. Mr. Walter has already spent $40. How much more can they spend on groceries? Well, their max amount is $125. So notice $125 is their ultimate end here. He's already spent $40, so that's why we've got $40 added on to X. And X is how much more can we spend so that we stay in budget. Well, to stay in budget, we don't want to exceed $125. So X, what you spend now, plus the $40, do we want it to be greater than $125? No. Do we want it to be greater than or equal to $125? No. We either want it to be less than $125 or less than or equal to $125. How do you know the difference? Well, think to yourself, would we be okay spending exactly $125? If we are, we would include this equal to portion. Okay. And the last one, Miles pays $30 for a ticket to an amusement park. He cannot spend more than $50. He cannot spend more. So that means he has to stay under $50. How much more money can he spend at the amusement park? So he's already spent the $30. That's why we're adding $30 each time. Our limit is $50. So if he cannot spend more than $50, we want to be here. Okay, please turn the page to page 498. And at the top, there is a property of inequalities, addition and subtraction, that's exactly like equations. It says that if you have an inequality, 2 is less than 4. 2 is less than 4, that's true. If you add the same amount to both sides of the inequality, does it still maintain being true? Is 5 less than 7? Yes. So the property of addition says that you can add the same amount to both sides of an inequality and the relationship's going to stay true. Same thing with subtraction. Okay, so look at example 1 at the bottom. We're going to solve this just like we did equations. When we subtract 3 from both sides, we circle those to make sure they're gone. We bring the x down, we bring the greater than symbol down, and 7. So the answer is x is greater than 7. Okay, so any value of x that's greater than 7 is going to make this true. So let's pick one. So pick something greater than 7. So I'm going to pick 9. If we put 9 in place of x, is 9 plus 3 greater than 10? Yes, it is. So that works. Okay. Top of the next page, same thing. N minus 5. So to get rid of the minus 5, please circle that. Cross it out. And we get n. Notice we bring the inequality down. N is less than or equal to negative 1. Now, if you don't like to see it that way, you can flip the whole thing around and write it like this, making sure that when you flip it, up here isn't the inequality opening towards the negative 1. When you flip it down here, you need the same thing. So n has to be anything less than or equal to negative 1. Okay, please pause the video, and I want to see your work on solving both of these, and then start again. Okay, the last step is once you have something solved, like here, excuse me, here's our solution. A is less than 1.5. That means that anything that's less than 1.5 is going to work in our solution set. So instead of listing out everything that's less than 1.5, which could be lots of things, I'm going to just start listing all these out. Aren't all these values smaller than 1.5? There's infinitely many solutions that are all the values less than 1.5, so we're going to learn how to graph these and put them on a number line. Okay, so on this number line, right here is halfway between 1 and 2, so there's our 1.5, and we want everything that's smaller than that. So notice that we draw an arrow, a thick arrow, saying anything that falls down here is going to be a solution. But now if you look right at 1.5, we don't want it to be equal to 1.5, we just want it to be less, so we use what's called an open circle. Meaning we're not including 1.5, but the second we get smaller than that, we're going to be good. Okay, so off to the side here, if you have an inequality that has a less than or a greater than, when you graph it, you are going to use an open circle at the endpoint. If you have an inequality that has the greater than or equal to or less than or equal to, we're going to have a closed circle, meaning we do want to include that endpoint. Okay, so let's go down to this one. To solve this, we would add 6 to both sides, and we would get our solution. X is less than or equal to 10. So when you graph these, you can put your target number right in the middle, and I want to see one number above and at least one number below. So this is how you would set this up. And we want to show all values of x that are less than or equal to 10. So since it's equal to 10, we're going to put a solid dot at 10. And we're going to draw an arrow whichever way shows values that are less than or equal to 10. So that would be down here. And there's our graph. Okay. Please turn the page. And I want you to complete guided practice 1, 2, and 3, and then come and show it to me, and then you can begin your assignment. Your assignment will be on the next page, independent practice 1 through 12. And 26 to 28. Okay, go ahead and get started.